Okay, this is video number 3, working with counting principle, binomial expansions, and factorials. On this one, we're just practicing working with, well, that's not in focus. We're practicing working with factorials. So this would be 8 times 7 times 6 times 5 times 4 factorial over 3 times 2 times 1 times 4 factorial. And there's a reason I didn't keep going from here, because I saw this 4 factorial and I figured, well, all of that cancels. And then 3 times 2 is 6. So now I need, well, 8 times 7 times 5. And I get 280 for this particular problem. I would probably give you a calculator, and you could plug this in pretty easily. However, we're going to see problems like this where they use variables, and then a calculator won't be helpful. The next one, this becomes 13 choose 5. That's 13 factorial over 13 minus 5 factorial times 5 factorial. 13, 12, 11, 10, 9, what is that, 8? So what can I cancel? This 8 factorial cancels with an 8 factorial. 5 times 2 is 10. 3 times 4, well, 4 times 3 is 12. So I need 13 times 11 times 9. 13 times 11 times 9. And this becomes, we can also let our calculator do that for us. So it was, I just forgot, 13 choose 5, 13 choose 5, and that's that same value. But here is why we need to make sure we know how to do it by hand. So this is n plus 2 factorial over n plus 2 minus n factorial times n factorial plus n factorial over this little n minus 1 factorial, and then n minus 1 factorial. Okay, we might need some more paper. On this one, this is the n's cancel, and so this becomes n plus 2 factorial over, because n minus n, they're gone, so this is 2 factorial n factorial. This next one, the n's cancel, this becomes a positive 1. Okay, so from here, n plus 2 factorial means n plus 2 times n plus 1 times n, and then it keeps going from there. So this is n plus 2 times n plus 1 times n factorial all over 2 factorial n factorial. The next one is n times n minus 1 factorial all over, well, 1 factorial is just 1. And actually, 0 factorial is also 1. So now, in this first one, my n factorial will cancel with an n factorial. My n minus 1 factorial cancels with an n minus 1 factorial. And so I am at n plus 2 times n plus 1 all over 2 plus n. If I wanted to put it all together, this becomes n squared plus 3n plus 2 all over 2 plus, well, 2n over 2. So your final answer could be something like n squared plus 5n plus 2 all over 2. Sorry about that, falling off the page.